Hi, I am Robin Delory for the VGS online tutorial series at UC Louvain. In the previous video, we have seen how to manipulate 3D brace structures. In this video, I will introduce you to the modeling of folded structures. So first, we'll take a look at how to ensure a stable geometry and how to make it isostatic. Then, we will see how we can use VGS to analyze such structures. So first, to understand the key geometrical requirements, let's isolate one fold of our structure. To do so, I will simply use the grasshopper interface. I can turn off the Visualize Diagrams component that comes from the VGS tab. I can also turn off these surfaces. And I will simply turn on the edges of one fold. Now, let's see if we can identify a pattern. Of course we can here. So what you can see is that you have triangles everywhere. So your structure really needs to be fully triangulated in order to work, and this is really crucial. But obviously that's not all, and that's not sufficient by itself. So something else that you may want to be careful about is ensuring that your structure cannot slide. See, for example, here I could move my structure around, and that's not my goal. So how can I prevent this? Well, a way of doing it is to simply decide to fix one point, in this case the one here, in 3 directions. But what about the other points? What do we need to do there? Well, let's take a look at another file and understand why such structures are called folded structures. To understand the folding pattern of our structure, let's use the crane solver. So what you can see here is that my structure can really deform, and this is purely based on the geometrical properties of my folded structure. Now what's interesting us right now is to take a look at how the supports react to it. So here, for example, when I unfold, what you can see is that the points are moving upwards. So when they move upwards, it means that I need to block all my supports in the Z direction. Now, what about other directions? Let's look here. When I fold it, I can see that my supports are moving inwards. So my supports also need to be blocked in the X direction. Now that we understood this, let's actually fix it in the grasshopper. So this is the thing you can see here, that all these points, so all of them except the one that's already blocked in the 3 directions, are now blocked in the X and Z directions. And this is important, but is that enough? Now that's another question. So let's take a look here. So you can see I have my evaluate equilibrium component from the VGS tab, and out of the model I can input a panel. And when I do this, I can see here that I still have 6 internal mechanisms. So this is an issue. It means that I'm simply lacking some bars, because the degree of hyperstaticity can be calculated based on the number of bars, nodes, and reactions. So here, a simple solution would be to simply add 6 bars of bracing. Now, to understand how we could do that, let's go back on the other file. Now, what else can we see when we try to follow our structure? Well, you can see that the structure can fold very closely here. So how to actually prevent this? Well, maybe by using elements that are gonna block this folding pattern. So let's go back on the other file and take a look at that. A good way of tackling this issue is just by adding bars, but on strategic points. So for example, here I decide to add these bracing elements on the last support. So you can see it's 1, 2, 3 there's on the last fold, and on the first fold. In doing so, normally it should be fine. Let's see if it is the case. Yes, you can see that again from the same output of the evaluate equilibrium component, I can see that I now have zero internal mechanisms. Well, this is already quite a great news. Now that our structure is statically determinate, we can finally use VGS. So just as a matter of simplicity, I will preview off everything. So to do so, I just select all the different elements. I click on preview off, and let's simply turn back on these surfaces for a clearer view. And let's turn on the visualize diagrams component from VGS. Let's also turn on the visualize diagram that's related to our force diagram and not only our form diagram. And let's change view to see what appears here. So of course I need to calculate my geometry. So this is gonna be loading, might take a little bit of time. Now my structure is fully calculated, and great. So I have my force diagram, I have my form diagram. Now if you want to take a closer look at your structure, it is also possible to plug in here the node ID and to start playing around to understand where are the biggest stresses. So here you can see that this is appearing on the first fold, so we can guess from there that it's on the extremities that we have the higher stresses, whereas here in the middle it's much smaller, obviously. Another tip that I can give you is if you need to scale down the size of the force diagram, you need to scale down your load immediately, because there is no other way to simply scale down the shape of your force diagram. That's it for this video. We hope this tutorial has given you a better understanding of how to model stable folded structures that are suitable for a VGS analysis. In a future video, we'll look at how to use VGS to analyze self-stress structures. We invite you to follow us in our series of VGS tutorials to learn more about structural design with 3D graphic statics. See you in the next video.